My name is Chris Yee and I'm making a 3D puzzle platformer called Nectar. In the game you play as a potted sunflower with its bumblebee companion, using nectar to grow plants, solve puzzles, and manipulate the world. In this episode, I'm going to talk about rope. And you're probably thinking, hold on, haven't you already made a devlog about rope? And yes, in fact I've made two. But there are two very good reasons why I'm doing a third rope-related devlog. Well, there's one good reason. The second one is a little silly, I'll get into it later, but let's begin with the good reason. So I was trying to make a change to the rope in my game. Just a small tweak, it was nothing big, but the blueprint for my rope was just way too complicated. Making even just one small tweak to the rope involved digging through piles of spaghetti code in my gigantic tightrope blueprint. And the thing is, I coded the rope a really long time ago, so I forgot exactly how it worked, and it was actually incredibly difficult for me to follow the code and figure out how it worked. So I decided I needed to make a change. I ended up scrapping my code entirely, and I started a new blueprint from scratch. With this new rope blueprint, I had three main goals in mind: simplify the code where I could, organize the code in a way that was easier to understand, and optimize the code for better performance. I have learned a lot over the past year and a half of developing this game, and I knew that I could improve in all of these areas. Speaking of improvement and learning, first I wanted to give a big thank you to the sponsor of this video, Brilliant. One of the biggest things I improved upon during my game dev journey is my use and understanding of vectors. Vectors come into play in game development all the time. Even with this rope, attaching the tightrope from post to post, spawning flowers in the correct positions, moving the player along the tightrope, it all involves a deep understanding of vectors, and Brilliant's vector course helped me understand the fundamentals in a way that made sense to me. Instead of watching lectures and reading textbooks, Brilliant takes a more engaging and hands-on approach. Rather than relying on memorization, Brilliant focuses on critical thinking and problem solving. My favorite part of Brilliant is that it uses real-life applications to teach its concepts. So the vector course that I took begins with the goal of programming a spaceship-style video game, and it uses vectors to move the ship and activate power-ups. And through this, the course teaches the basics of vector operations like scaling, transformations, polar coordinates, dot products, and it applies all these concepts to things like game development and logo design. And this approach is really engaging for me as a game developer. To try everything that Brilliant has to offer for free for a full 30 days, visit brilliant.org/nerdchomp or click the link in the description. You'll also get 20% off an annual premium subscription. Thank you again to Brilliant for sponsoring this video. Now back to my rope. With my three goals in mind, simplify, organize, and optimize, I started with simplifying. So my approach to the functionality of the rope is basically the same. I have the tightrope and I have the slingshot, and I decided to keep them separate this time in their own separate blueprints. They are functionally completely different from each other, even though they do share the same components of the rope. But keeping them separate just helped me take a simpler approach to my code, keeping a clear delineation in functionality. Speaking of simplified tightrope code, there were so many requests for me to do a tutorial after my first rope video, and I know that for whatever reason on the internet there's basically no online resources for creating a tightrope in Unreal. I personally couldn't find anything myself, and I don't know why. It's one of the reasons why it took me so long to figure it out myself. So I thought I'd make a little sample project with just a bare bones tightrope blueprint. I made a separate video explaining how the blueprint works. Over there you'll also find a free download of the sample project. It's free for you to use however you'd like. You can poke around, see how it works, or you can try to modify it to use in your own projects. So take a look, have at it, do what you want, it's all yours. The second goal of my new rope was to organize, and one of the biggest things I've learned over the course of my game dev experience is the importance of staying organized. All of my early code is a complete mess, and it's virtually impossible to explain to anyone how it works. For the updated version of my rope, I made use of functions to package reusable code into concise nodes that clearly describe what they do. I no longer have giant spaghetti messes anymore, and now I have more modular code that's easy to follow. So if I want to change something in my code, I don't have to sift through a pile of spaghetti anymore. With my current setup, it's actually quite easy to find things if I want to change something. And then my third goal was optimization, and there were two big optimizations I made. My general approach to the rope is still basically the same. I generate a spline, I create a spline mesh that follows that spline, and then I have the spline follow an attach point that is controlled by a physics constraint. But in my old version, when I create the spline, I would create a spline point every 15 units in Unreal. And splines are actually somewhat expensive when it comes to performance, especially if you have a lot of spline points. Each spline point stores a location and tangent information, and I was updating the location of every spline point every single frame on tick. So if I had a rope that spanned, let's say, 300 units, which is very likely, that means that I would generate 20 spline points and 19 spline meshes, and they would all be updating on tick. Now, my new rope, and how I decided to optimize this, was I still use splines, but regardless of the length of the spline, I only ever have 3 spline points. There's the start of the rope, there's the end of the rope, and then there's a point somewhere in between those two. And then I only have 2 spline meshes connecting those 3 points. So the start and the end, they never change, they always stay the same, so I don't need to update them. The only thing I do need to update is the position of the point in the middle. And that basically just follows the position of the player along the tightrope. And there really is no need for all those extra spline points, so I'm not losing anything visually or fidelity-wise. It all looks exactly the same. It just performs a lot better now. It greatly reduces the amount of data that needs to be calculated and stored. The second main optimization I made was the use of tick. So while my new rope still uses tick to update the position of the spline in spline mesh, I control my use of tick with a gate. So I only ever use it when I need it, and then when I don't need it, I shut it off. So I open the gate when the player jumps on the tightrope and is walking on the tightrope and the rope needs to be bouncing up and down. I also open the gate when I'm using the slingshot. When it's being pulled back, then I need to update the look of the rope. But then if I'm not interacting with the rope at all, if I'm not on the tightrope or if I'm not using the slingshot, then I can close the gate because the rope isn't moving at all. It doesn't need to update. And there are a few other small optimizations I made, like using instant static meshes for the slingshot projections instead of actors, which was what I was doing before. Little things like that. And I did a stress test comparing the old rope to the new rope. I set up like a blank level and I made a circle of 24 tight ropes. I connected them across the map, and then I compared the frame rates. So the old rope dropped to around 20 frames per second, which is not great. The new rope, though, stayed at right around 120 frames per second, with just a few small dips. But for the most part, it was basically unaffected. In addition to all these changes, I also made some changes based on your comments in some of the other videos. So, an overwhelming number of people suggested that the plant character pulls back the slingshot instead of the bee, because before I had the bee pulling it back and the character would disappear. A lot of people thought that was weird. I agreed, so I changed it, and I think it looks a lot better now. And I also changed the slingshot trajectory path thingy. It used to be just a spline, like a glowing spline that showed the path, but I got rid of that and I changed it to a moving projection of the object that you're firing. It's just a little more dynamic looking, it looks a little nicer. So those are all the upgrades I made in the new version of my rope. Even though it was a tough decision to scrap my rope and start from scratch, I do think it was ultimately the right decision. I was able to improve the rope in pretty much every single way. So now my overly complicated rope, while still complicated, is easy to follow and easy to modify. Now earlier I teased a little silly second reason why I made this video about the rope. The other 2 rope-related devlogs that I made outperformed all of my other videos by a landslide, and I have a theory that YouTube's algorithm favors videos about rope. Or maybe just people on YouTube like rope for some reason, I don't know. Either way, I wanted to test this out. So if this video performs like the other 2, and it does super well, I'll take that as confirming that my rope theory is correct. If this video flops, then I guess it's just a fluke. But this is just a little experiment to test whether my rope theory holds any ground. What do you think? Do you like rope? Do you think YouTube likes rope? Do your friends like rope? Comment down below what your favorite rope is. And once again, thank you to the sponsor of this video, Brilliance. Thanks.